Hello again, everybody. Mr. Walden here, going to give you a short video lesson on simplifying square roots that do not have an integer solution. Those would be the types of square roots where if you took the answer and put it in the calculator, or you took the problem and put it in the calculator, you would get a decimal answer on your calculator. Teachers generally want you to not answer the question that way. They want you to break it down if it can be broken down. And I've noticed a lot of times my kids have a bit of a problem doing that in Algebra 2 and Geometry when I'm starting to teach the Pythagorean theorem or perhaps the quadratic formula. So I'm going to try to give you a little overview here on simplifying square roots. I built a list of the numbers up to 225 that have integer square roots. What we're going to do is we're going to work through problems that aren't on that list. And we're going to try to see how we can use that list in order to help simplify the examples that we have here. Number one is the square root of 20. If you put the square root of 20 in the calculator, you're not going to get some pretty answer. You're going to get a decimal that's somewhere between 4 and 5. The reason you'll get that is because 20 is somewhere between 16 and 25. If I want to try to simplify that and get a piece of it to have a square root, what I will do is I will start right here where it's between them, and I'm going to go backwards, and I'm going to see if I can get any of those numbers to go into 20 evenly. For example, will 16 go into 20? No, it will not. Will 9 go into 20? No, it will not. How about 4? As it turns out, of course, 4 does go into 20. We can break it apart then as 4 times 5. We have a property that says if you've broken it apart into its factors, you can take the square root of the factors separately. And now we actually know the square root of 4. It's 2 times the square root of 5, which we don't know, for a final answer of 2 square root of 5. And that, everyone, is generally how a math teacher in upper level is going to want to see the answer, instead of a decimal between 4 and 5. Let's move on and work another one. Square root of 45. Okay. I'll reset this over here for you. 45 is between 36 and 49. So I'm going to work backwards, see if I can get something to go into 45 evenly. 36 does not. 25 does not. 16 does not. But 9 does. The square root of 45 can be broken apart in 9 times 5. I'll then take the roots separately. And now we see that 9 has a square root of 3. We don't know the square root of 5. So this answer, simplified, is 3 square roots of 5. I'm going to move on and work a few more for you, or with you. Okay, square root of 75. We'll go over, check our chart. 75 is in between 64 and 81. So let's work our way back. Will 64 go into it? No. Nor will 49. 36 doesn't go into 75 evenly. But 25 does. So the square root of 75 can be broken apart into the square root of 25 times 3. When we take the square roots separately, it looks like this. And then we know that the square root of 25 is 5, right here, 5, times, we don't know the square root of 3, so the simplification is 5 times the square root of 3. 72, the next problem, is a very interesting problem because there are, on the list, several numbers that will go into it. As it's written, 72 goes right there. And this is why I'm going to try to teach you to go back up the list. Will 64 go into it? No. 49 won't. But right there, 36 will go into it. This is the square root of 36 times 2. So we break it apart into its separate roots. Square root of 36 is 6. Don't know the square root of 2 for a final answer of 6 square root of 2. The reason I say that, the 6 square root of 2 is the most simplified answer. And if you had gone from the top down on this problem, you would have found that 4 went into it. 4 and 18. If you had skipped 4 for some reason and went to 9, 9 goes into 72. 9 times 8. So a lot of times you go to work those and you say, well, it's 2 square root of 18 or it's 3 square root of 8. And I would say, well, yes, it is those. But those aren't fully simplified. There were numbers that would have come out of those with nice, pretty square roots that you could have taken further. That's why I think that we should start where the number is and work our way back towards the top. Try not to start at the top and work your way down. A lot of times that's just going to lead to trouble for you. Let's work a couple more ends. Alright. Now you'll notice because I wanted you to see a couple that were larger, I put some that are not on the list. They're beyond the list. They go on further. But we can still use this list to try to work them out. For 363, 225 won't go into it. Nor will that. Again, a negative. Nope. But 121 goes into it. So we have the square root of 121 times 3. We will separate them. Square root of 121 is 11. So 11 square root of 3. 600. I think you can probably see where 600 is going to go here. No. Bingo. 100 times 6. Separate them. Square root of 100 is 10. Do not know the square root of 6. Final answer, 10 square root of 6. Okay. I hope that's helped everyone. I did put a couple of student problems on this, and what you can do if you wish to work these out yourself is pause this video at any time now, work them out, and here in a few seconds on your video when you restart it, I'll have it worked out for you on the screen. So like I said, if you'd like to take this opportunity to work a couple yourself and just see how you're doing, pause this video at any time in the next few seconds, work them out, and then I will go to another page that has the answers. Ready? Let's go. Giving the answers in 3, 2, 1. Bingo. Okay, everyone. There's the answer to those two problems. Hope you got them right. If you need any more help, please come see me during your free period. And I hope that this has been something that can help you. I'll make a few more videos in the next few days with some more simple math. And if you need any more help, just come see me, guys. Thanks.